Let's solve this problem. Calculate the total mass of a disk of radius r, whose density increases with the radius as this function here. So the density is equal to 1 plus rho squared. This means that at the center of the disk, the density is equal to 1, and at the edge of the disk, the density is equal to 1 plus r squared. Okay, so this means that we have a disk. Let's draw it in 3 dimensions. So we have a disk which is lighter in the center and it's heavier in the edge. Okay, and actually the density, if we plot the density as a function of radius, so let me use the same notation, rho as a function of radius. Yeah, so this is increasing like a quadratic, 1 plus rho squared. So the density is higher on the edge, and this is changing in a continuous way. But thanks to double integration, we can calculate the mass of this disk. Okay, so remember the radius is r. So how do we calculate the mass of a disk? We do the double integral on the area A of the density times dA. Since this is a disk, we choose polar coordinates. Okay, choose polar coordinates. So in polar coordinates, dA is given by rho times d rho times d phi. Never forget the Jacobian. And the area A is given by rho changes between 0 and r, and phi changes between 0 and 2 pi. Therefore, we can now do the mass. Mass equals the integral of 0 to 2 pi of the integral between 0 and r of rho times dA. So let's write it first, rho, and then I write dA, which is, sorry, this is not called rho. This is the Greek letter called sigma. I have been saying rho all the time. This is sigma, and this is rho. Yeah. So sigma is the density of the disk, while rho is the radius. So rho d phi. But we know that sigma is this function here, 1 plus rho squared. So we substitute it. Times rho d phi. Now, this can be written as a function of rho times 1, which is a function of phi. So we can do separation of integrals. So we can do this is equal to the integral from 0 to 2 pi of d phi times the integral from 0 to r of rho plus rho cubed, right? I just expanded this rho times 1 plus rho squared. So the result of the first integral is 2 pi, and the result of the second integral is 1/2 rho squared plus 1/4 rho to the 4 between r and 0, and this is equal to 2 pi times r squared divided by 2 plus r to the 4 divided by 4. And this will be the total mass of this disk. Okay? We could simplify this slightly by saying this is pi times r squared plus pi r squared times 1 plus r squared over 2. Okay? Excellent. So see you in the next video.